How do you do that in software, or hardware for that matter? In kind of the way I explained it, maybe lend to think you store 25 bits, which is a weird number, in one register, and then have 25 bits, 25 bits, 25 bits. That's 64 of these registers. This is weird. What we are going to do is, you store one of these, the first row here, this is one word, so this is one word for 64 bits. This is the next register. So the whole state are stored in 25 words, so each word is going this direction. Each word is 64 bits long. Modern Intel CPUs have 64-bit registers, so this fits into one register. If you have an ARM CPU on your Android phone, you have to take two 32-bit registers to store that. You know what I'm talking about? So these, you can see that these 64 bits you put in one register, the next 64 bit in one register. Which has the advantage that each of these registers has now a coordinate with an x coordinate between 0 and 4 and a y coordinate between 0 and 4, right? You have 25 registers, 25 Variablen, each variable has 64 bits. Okay. So now we get kind of a soft review. So our input is this array B with x and y coordinates, and this is exactly what I just told you. So x, y are running from 0, 1, 2, 3, and 4. So this is an array, right? Software speaks. This is an array. And the output is another array. So we do that, and there's a simple formula to that, namely A of these A words are... Oh, I'm wrong. Okay. I'm wrong. This... okay. Yeah, so this is A, this is B. I was on the wrong page of my notes. I'm sorry. Bad, Professor. Okay. Yeah. So what you're doing now is you do things. So old step. You rotate. That's OE, this RO connotation. Each word is rotated by a fixed number of positions, and I'm going to give you that fixed number in a second. This is this funny table there, okay? Position CF, compare ist das gleiche. Table 1.3. Meaning in pseudocode we can write temp, temp is a temporary variable. Temp of x, y is the rotate function of a x, y, comma, and r is a table value. So this is table entry. I see a lot of fragende Gesichter, right? Confused faces. What does it mean? For instance, these are 64 bits going to the tape, right? This is like this big, they call it actually in the catch-up document lane, between the Straße, right? The street going into here. So this, for instance, would be A 0.0, right? This is one register, 64 bits with the coordinate 0, 0 because at this point here, right? This has to be rotated by how, and these are 64 bits long, so how many positions do we rotate that? What do you guess? Well, we have to look in the table, and it says 0, 0 is here. Okay, that's a bad example. That has to be rotated by 0 positions. Okay, so let's look at this here. So this is a 1.0, right? So by how many bit positions do we have to rotate bits? So x is equal to 1, is equal, this has to be rotated by 1 position. The next one, 2, 0, which is here, right, has to be rotated by 62 positions. Why? Because it's cryptographically secure. Okay, we just do functional description here. So that's the whole step, and then the by step is permute the rotated words. It means after you permuted each of the lanes, each of the words, you exchange those words. Following the rule, uppercase B, the output of the algorithm is B, it's with coordinates y, 2x plus 3y is the temporary lane at location x, y. And here, then you run from x, y runs from 0 up to 4. Example. So input word, input lane, let's pick A 3, 1. we're talking about Coordinate 3.1 is we're talking about this lane. Right, these 64 bits that go into the table that way, right? What's going to happen with those? The whole step does the rotation, so means we compute a temporary variable at the same coordinates, temporary area. Hills area, that's the operation. You rotate your original A word, diese Original 64 bits here, right? The original 64 bits. You have to go into your rotation table and you look at the location 3.1 and you see the 55 here, right? You rotate that by 55 positions, from table 1.4 in the lecture notes, right? This is here. That's the Rho step, and now the pi step, Permutationsschritt. In order to compute the output B at the location 1, here's y ist gleich 1, and now we have to evaluate this really complicated formula, which is of course not really complicated, which is 2 mal 3 plus 3 mal 1, which is B of 6 plus 9, 1, is that right? 9, yeah. How do you deal with that? There is no coordinate 9, right? It stops at 4. Any suggestions? How should we deal with that? How do we deal with it? Yeah, modular what? Modular? Yeah, because it's 5, everything is nothing bigger than 4, exactly. So we do modular arithmetic, so this is... Stimmt das? Ja. Excellent answer, so this is mod... It's always taking modular 5. And so this is just called... And what is this equal to? Well, we're looking at this word, so this is equal... So in this position, right, output 4 gets assigned this value here. Okay, so you're rotating the words, right? No, you're commuting the words, right? It was before education 3.1, you put this now education 1.4. Okay. So these were the... When P1 and the last two ones, G and Iota, are luckily relatively pain-free. This is not us here. This is the step, shy step. So here again, our input is now B of x comma y, which is what we just computed. Good to have Stefan in the class.